Welcome to this explainer. Today, we're taking those high-level, highly theoretical design concepts and dragging them right into functional, scalable front-end code. It is an awesome process that really bridges the gap between human empathy and strict technical logic, ultimately turning pure design intent into everyday user reality. Let's get started. Here's our roadmap for today. We'll be hitting 6 key points. First, decoding UI versus UX. Second, mapping the customer journey. Third, mastering the Figma handoff. Fourth, building for responsive reality. Fifth, scaling with atomic design. And finally, reusable and accessible components. Section 1, decoding UI versus UX. Okay, let's dive into this. We have to start by looking at a classic piece of historical friction in the tech world, which is what a digital product looks like versus how it actually feels. UI, the user interface, is purely the presentation. It's the tangible stuff, the elements you physically see on the screen like buttons, colors, and typography. But UX, the user experience, is the flavor and the overall feel. It answers a fundamental question for us. Does this application intuitively make the user's life easier or harder? Great UX is when a user knows exactly where to press or click without even consciously thinking about it. Now, bridging these two concepts requires us to step entirely out of our developer or designer shoes. Great UX starts with pure empathy, period. We have to predict user psychology and actively solve human problems long before we ever open a code editor or write a single line of CSS. Because if we don't understand how our user thinks, our code is basically just building a beautiful maze that has no exit. Applying that psychology really takes critical thinking. First off, we absolutely must reduce cognitive load by keeping interfaces incredibly simple. You never want to overwhelm the user with unnecessary choices. Second, we have to anticipate errors. People make mistakes, so we need to design forgiving forms with clear, actionable error messages that actually help them. And third is visual hierarchy. We use size, space, and color to naturally guide the user's attention right to the key actions we want them to take. Section 2, mapping the customer journey. Let's trace how that psychology actually plays out chronologically. You can map the customer journey as a sequence of user emotions across different sequential touchpoints. Think about it. It usually starts with an action. The user touches or clicks the app. Then there's often a loading state, which is that dreaded wait time. This instant triggers an emotion. If they're waiting too long, or if the interface suddenly gets confusing, boom, they hit a pain point. That's friction. Our entire goal here is to smooth out this specific sequence. From a developer's perspective, mapping this journey demands a total shift in mindset. We cannot just build isolated pages anymore. We have to build intuitive flows. We need to intentionally design loading states, specifically to reduce user anxiety while they're waiting on data. And we've got to ensure that our front-end component states match the user's exact expectations at every single step of the way. Moving right along to Section 3, mastering the Figma handoff. A clean developer handoff is what actually turns design intent into pixel-perfect code. So what does this mean practically? It means knowing how to extract exact CSS properties using the Inspect panel. It means exporting tailored, highly optimized SVGs for front-end builds. It means understanding how Figma's auto layout maps directly to your CSS flexbox behavior. And crucially, it requires strict standardization. For example, taking a totally random design anomaly, like, say, a 13-pixel font, and forcing it into a standardized global variable like 16 pixels or 1 rem.
Section 4, building for responsive reality. This is where things get unpredictable.
I absolutely love this quote. Figma provides a static snapshot across specific devices. As developers, we must build a fluid, continuous experience that works everywhere. That is literally the core philosophy of modern front-end development. A design is just a beautiful picture of a perfect scenario, right? But the code actually has to survive reality. Surviving that reality requires a rock-solid foundational approach. First, mobile-first CSS. You start with your base mobile styles and you scale up using min-width media queries. But we balance this by constantly, always planning for edge cases. Think about it. What happens when a user's name is 40 characters long? Or what happens if they're viewing it on an ultra-wide monitor? Dynamic content links and completely unexpected resolutions are just the reality of the fluid web.
Section 5, scaling with atomic design. Now, what's really interesting here is how we architect this.
To build robust architecture, we actually use a subtle chemistry analogy. It all starts with atoms. Think back to high school chemistry. Atoms are the smallest indivisible building blocks. In our UI, atoms are the raw HTML tags. A standalone button, a single text input, our color variables, and our base typography. You literally cannot break these down any further without them losing their function. But when we take those foundational atoms and bond them together, we create slightly more complex, functional units called molecules. For instance, if you take a text input atom and you bond it with a button atom, you suddenly have a fully functional search form molecule. Scaling up again, we get organisms. These are distinct, complex sections of the user interface that are composed of groups of molecules and atoms all working together. Think of an entire site header. That header contains a logo atom, a navigation molecule, and a search molecule, all living together as one cohesive structural organism.
And finally, we place these organisms into templates. Templates are page-level objects that provide the underlying content structure. They don't actually dictate the final data, but they give our assembled atoms, molecules, and organisms their final layout on the screen.
Now, to manage all of this at a massive enterprise scale, we use tools like Pattern Lab. This compiles our atomic design concepts into centralized, living design system documentation. It essentially creates a single source of truth. So if a company suddenly decides to change their primary brand color, updating that one single atom in Pattern Lab will safely and instantly reflect globally across hundreds of diverse enterprise applications. It's a real game changer.
And that brings us to Section 6, Reusable and Accessible Components.
When we're organizing our CSS, we have to avoid hard-coding specific hues, like you don't want to map a variable to -red 500. Instead, we really should use semantic aliases, like -color error. Color dictates emotional response and usability, right? By using semantic aliases, our code describes the actual purpose of the color, not just what it looks like. If that error color ever needs changed to orange, you definitely don't want to be rewriting your entire code base. So the absolutely crucial point here is accessibility, which is often abbreviated as A11Y. We have to ensure our interfaces are usable by everyone. Contrast ratios must strictly meet WCAG standards so your text is actually readable. And perhaps most importantly, we must never rely on color alone to convey critical state information. For example, a red border on an input isn't enough to indicate an error for someone with colorblindness. You also need a clear warning icon or some helpful text. To wrap up our technical workflow, our ultimate strategy is simple. Build once, use everywhere. We achieve this by fully decoupling our complex business logic from our UI presentation. We expose modifiers, like setting a button variant to primary or secondary, so it can adapt visually on the fly. And we design slotting for child content. This empowers authors to assemble and modify pages dynamically without ever requiring a developer to go in and write massive code updates. As we conclude this explainer, I really want to leave you with this question. Think about the digital tools you use the absolute most. How do your favorite everyday apps apply this exact user logic and scalable architecture to keep you intuitively engaged without you even noticing it's happening? The next time you tap a button that just feels completely right, remember the psychology, the atomic design, and the pure empathy that went into that single line of code. Keep exploring, keep learning, and I'll catch you on the next explainer.